Namaste. In this problem statement, these are the two important points. Each child must get at least one candy. At least means more than one candy. So basically, it's like each child must have at least one candy. Minimum one candy must be with the one child. Okay, with each child you have to be giving the one candy. Second point is children with a higher rating get more candies than their neighbors. Again, read it. Read the same particular line 3 times or 5 times. It's very important. Children with a higher rating get more candies than their neighbors. Okay. Now, what do we mean by this? Let's understand the scenario with the first test case given in the problem statement. So, this is the first test case. Here, they have given and mentioned in the first point that each child must be given one candy. So let us give them. Now I am giving here one candy to this person, one candy to this person, and one candy to this person. Now you will say that, sir, the second person has the rating of 0. Then will you provide the candy? Will he or she deserve? Yes, they deserve. Okay, rating is not judging about the personal character. Okay, you should not judge a book by its cover page. So you need to provide the candy to each and every person. Now the point here is you need to make sure that the person with the highest rating should have more candy than their neighbors. I repeat, the person with the highest rating must have more candy than their neighbors. If you look at the third person has highest rating. How much? The rating is 2. See, and their neighbor has the 0 rating, but still both have same candies. It should not happen like that. So the third person should get higher number of candies compared to their neighbors. How much higher number of candies? Okay, it is not like the third person has the highest rating, so you are giving them 100 candies or 30 candies. No, you should make sure that you are providing the overall minimum number of candies. If you want to get the overall minimum number of candies, means the person with the higher rating should get one more extra candy than their neighbors. The person with the highest rating should get only one more extra candy than their neighbors. It's not that 30 candies or 100 candies you are giving for the highest rating, right? Now let me provide them one more candy. Okay, fine. So it means the third person has total 2 candies. Now again, is the everything perfect? No. If you take a close look at the first person, here our first person has the rating of 1. Now compare with their neighbor. Their neighbor is another second person with the rating 0, and both have the same number of candies. It means we are violating our rule. In order to make sure our rules are not getting violated, what we need to do? You should provide one more extra candy to the highest rated person, right? It means I'll provide now one more extra candy to the first person. Now in total, how many candies our first person has? 2 candies. Now if you take their sum, total how many candies we have? Our first person has how many candies? 2 candies. Second person has only 1 candy, and our third person has 2 candies. So total it will boils down to 5 candies. That's what it is mentioned in the test case. If you take a closer look at the first test case, this is what given here. This is the input and this is the output. This is how you are getting the 5 as the ultimate output. Now let us work out on the second test case. Now this is the second test case. Now I request you people to take 3 minutes of time or 4 minutes of time. Okay, let me wait for 4 minutes and try it yourself. Okay, guys. Now I hope you have tried your best. Come on, let's see the strategy how to solve this particular second test case. If you observe here carefully, obviously the default rule is 1 candy to each person. Okay, 1 candy to each person. Now is that enough? You tell me. Yes, you only. You tell me. Is that enough? Everything is perfect? No. If you take a closer look at the second person, second person has the rating of 2 and compare with their neighbor first person, first person has the rating of 1, yet first person and second person both have only 1 candies. It means it is violating our rule. Among the first person and second person has the highest rating, so second person should get 1 more extra candy than the first person. So let me provide 1 more extra candy because of the highest rating. Is that clear? Now if you take a closer look at the third person, there is there any need to provide the candy, do you think? No, not at all. Because the third person has the same rating with their neighbor, the second person. Okay, so there is no need to provide the candy, extra candy to the third person. Now in total, how many candies do you have? First person has 1 candy plus second person has 2 candies plus third person has 1 candy. In total, it boils down to how many candies, guys? Excellent. Total 4 candies. Great. Now, let us go to the hidden test case. Now, this is the hidden test case I am interested in. And now, let me provide you your own kind of, I am giving you people, okay, take 10 minutes of quality time and try to solve this and come up with the output. Let me wait. Now I hope you have tried your best. Come on, let's cross check. Okay, guys. Now, definitely to do this particular thing, it's a bit confusion. Yes or no, guys? See, you might have tried your best, but I am sure, I'll bet that those who are watching this particular video, each and every person might have got different answers, but that should not be the case. When you are solving a test case, when you are working out on the test case, everyone should get the same output. Now, sir, how can everyone get the same output? We have a trick, okay, and that trick only we call it as logic. Now, what's the logic behind this? Please observe here. The logic behind this is, let me reveal you the logic behind this. As usually, we know that, I repeat, as usually we know that we need to provide 1 candy to each and every person, right? So we have provided to everyone. The point here is, now we have to do something like left traversal. Okay, first of all, let us do the left traversal. After left traversal, we have to do the right traversal. If you consider the left traversal, see, what do you mean by left traversal? Comparing with the left person. I repeat, what do you mean by left traversal? Comparing with the left person. Now you answer me, whether my first person has the left person. I repeat, whether my first person has the left person. No, my first person do not have the left person. That's why I'll straight away start my left traversal from the second person. Is that clear? Now, the second person, compare with one question, that is, now you are comparing and starting your traversal, left traversal from the second person. Now the question here is, whether my current person, whether my current person has highest rating than the left person, whether my current person has the highest rating than the left person, no, so they'll remain with the same number of candies. Moving forward, whether my current person, whether my current person has highest number of candies than the left person, yes, they have. At that particular time, what you have to do, how many candies your left person has, that count, and you need to add one more candy and give it to the current person. In that case, how much you will get? Yeah, so in that case, how much you will get? You will get here 2. Is that clear to everyone? Now again, moving forward, whether my, okay, whether my current person, whether my, this is my current person, whether my current person has the highest rating than the leftmost person, no, so that's why you will remain with the same number of candies. Next, again, moving forward here now, whether my current person has the more rating than the leftmost person, no, so they will also remain with the same number of candies. Now next, again, moving forward here, whether my current person has the more candies than the leftmost person, yes, so how many candies now you will get here? How many candies leftmost person has, that particular count plus 1, and you have to provide that particular thing to the current person. It means now you will do simply here how much? Yes, you will be doing 1 plus 1, so it will become the 2. Now again, moving forward, this guy, okay, now here I am, whether my current person has the more candy than the leftmost person, no, so they will remain with the same number of candies. Now again, moving forward here, whether my current person has the more candies than the, more rating, not candies, whether my current person has more rating than the leftmost person, yes, so what, how many candies you will get here? You have to provide how many candies the leftmost person has plus 1 to the, give it to the current person, so you will get here totally 2. Next, again, moving forward, this person is our current person. Now again, how, whether my current person has the more rating than the leftmost person, yes, now how many candies you need to provide to the current person? Now how many candies leftmost person has, add 1 to that and give it to the current person. It means you will get here 2 plus 1, 3 you will get here. Is that clear? Moving forward, now moving forward, if you observe, now here I am at the last person, whether my current person has more rating than the leftmost person, yes, so what you will do, you will need to give the more candies. How many candies? How many candies leftmost person has plus 1 and give it to the current person. So you will get here how much? You will get 4 here. Is that clear? Right. Now this is the scenario. Now what you have to do is, let us do the right traversal now. Okay. Let us do the right traversal. Now right traversal means what? Comparing with the rightmost person. I repeat, comparing with the rightmost person. Now you tell me whether my last person has the rightmost person. You tell me whether my last person has the rightmost person. No, my last person does not have the rightmost person. That's why I'll start my right traversal from the last but one person. So let me start my traversal from the last but one person. Okay, now again, compare the rating here, guys. Whether my, now here I am, from here I need to start, whether my current person has more rating than the rightmost person. No, so that's why they will remain with the same number of candies, which is 3. Now again, coming, it's like coming backward. Okay, whether my current person has more rating than the rightmost person, no, so they will remain with the same number of candies, which is 2. Now again, moving forward, whether my current person has more rating than the rightmost person, no, so they will remain with the same number of candies. Again, coming backward, whether my, here I am now in this arrow, whether my current person has more rating than the rightmost person, yes, So at this time now what you have to do is, at this time you need to make sure that you are taking the maximum of the current person candy. You need to take the maximum of current person's candy and the candies count of rightmost person plus 1. If you do that, how much you will get? How much you will get? You will get maximum of 2 comma 1 plus 1 means 2. It means in total you will get 2 candies only here. Now again moving backward here now, whether my current person has more rating than the rightmost person? No. So they will remain with the same candy which is 1. Now again moving backward, here I am now, whether my current person has more rating than the rightmost person? No. So they will remain with the same number of candies. Now I am here now moving backward, whether my current person has more number of more number of rating than the rightmost person? Yes. Now at this point, now what you will do again, you will take the maximum of current person's candy. Listen carefully. Now you are going to take the maximum of current person's candy and rightmost person's candies count plus 1. I repeat, now you are going to take the maximum of current person's candy and rightmost person's candy count plus 1. If you do that, how much you will get? You will get again maximum of 2 comma 1 plus 1, which is again 2. So you will get 2 only here. Now again moving backward, whether my current person has more rating than the rightmost person? No. So they will remain with the same 1 candy. Okay. Now again moving backward here, whether my current person has more rating than the rightmost person? Yes. At this time now what you will do again? You are going to take the maximum of current person's candy with the rightmost person's candies count plus 1. If you do that, how much you are going to get? You are going to get maximum of 1. Okay, you are going to get here now maximum of 1 comma, okay, 1 plus 1, which is 2. It means you are going to get the answer here as 2 now. Is that clear to everyone, guys? So 2 candies you are going to get. Now in total, how many candies totally? Now if you total it, you need to take the maximum of all this stuff. So if you consider here total 4 candies, getting my point? So let me write here 4 candies plus 3 candies plus 2 candies plus 1 candy plus 2 candies plus 1 candy plus 1 candy plus 2 candy plus 1 candy plus 2 candies. Now in total, if you compute this, how much you will get? 2 plus 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 plus 4, how much? It is 19. So in total, 19 candies you are going to provide to all the kids. Is that clear to everyone? Fine. Now let us see the logic part. Okay guys, now when it comes to the logic part, it's very simple. What is going to be our first line? What is going to be our first line? As we know that it's an array related problem statement, so obviously first line is going to be int n is equal to excellent ratings dot size. So in C++ we are coding this ratings dot size. It's very easy. This is going to be our first line. Now what is going to be second line? See, the second line, in the second line actually it should be like by default to all the kids. To all the kids. How many kids are present? N kids are present. To all the kids you have to provide one candy each. Think once. Yes, very good. So if you observe here carefully, how many kids are there? Total n kids are there, and to all the n kids by default initially how many candies you are providing? 1 candies. Getting my point? And this should be a vector. This must be a vector. So the kids must be the vector, because they are one is of integer type, right? So this is your second line, vector of int kids of n comma 1. So this is the kickstart of our whole logic and programming part. Now let us come and live code here. So if we code it here, you will get something like this: int n is equal to ratings dot size, and now here we are going to get vector of int kids. Okay, how many kids are there? N kids are there. And initially how many candies you are giving to all the n kids? So you are giving one candy each to all the n kids initially, right? Now if you consider here, now what you need to do, you need to do your left traversal. Okay, now how you are going to start your left traversal? Tell me guys, how you are going to start your left traversal now? Yes, excellent. You are going to do your left traversal from the first person. Now what do you mean by first person? First person means, I mean not first person, from the second person. Okay, first person means 0th index, second person means first index. Left traversal we have to do from the second person, right? It means index 1, and as usually I less than n and plus plus I. Okay guys, now what you need to do? You need to do the comparison with the current person's rating with the leftmost person's rating. Is that clear? Now see, what do you think? What is the current person's rating? It is, let me write it here. What is the current person rating? The current person rating is ratings of I. Now compare that with the left person rating. Now what do you think guys? What is the left person rating? It is excellent, ratings of I minus 1. Now compare it. Now how you will do that? You will do it like, if ratings of I is greater than ratings of I minus 1, because if ratings of I is, if current person's rating is less than leftmost person's rating, there is nothing we have to do, right? Now what you will do, you will make sure that your current person's candy count should increase. How much it should increase? It should increase in such a way that the current person should have one more extra candy than the leftmost person's leftmost person's candies count. So to achieve that, what you are going to do? Excellent, kids of I minus 1 plus 1. That's it. Now this is total left traversal. This is your total left traversal. Now let's perform our right traversal. Now can you tell me guys, from where I need to start my right traversal? Do you think my last person has the right person? No. So that's why I'll start my right traversal from the last but one person. Now last person means n minus 1. Now last person does not have any right person. So that's why I'll start from the last but one person. Last but one person means n minus 2. So that's why here I'll keep it as n minus 2, and let me do here I greater than or equal to 0, because still first person I need to go right, and obviously here it's I minus minus I, or I minus minus, both are same here in this scenario. Now again you need to compare with the current person rating. Now again guys, what do you think your current person rating is? What do you think your current person rating is? Obviously excellent, it is ratings of I. Now compare that with your right person's rating. Now the right person rating, what is the rightmost person's rating? What do you think guys? Think once. Excellent. It is ratings of I plus 1. Excellent. Now come on guys, let's compare this. If ratings of I is greater than ratings of I plus 1, now how much you will get? Now see, now what you need to do is make sure that your current person's candies count should increase. How? In what way? In such a way that you are going to take the maximum of, already I told you, right? Maximum of current person's candy, which is kids of I, and the candies count of rightmost persons plus 1. The candies count of rightmost person plus 1. It means, what is the rightmost person's candy count? I plus 1 plus 1 you have to do. Is that clear? Now that's it. This is the rightmost traversal approach. Now again, what you will do? Now if you consider carefully the kids vector, it has all the kind of, all the appropriate apt number of candies. Now what you need to do? Sum it up. Like it's like run it up. Hanuman kinds run it up. It is like sum it up. Getting my point? So how to sum it up? Int sum is equal to 0. It's a very easy technique. Already everyone knows it. Int I is equal to 0. I less than n and plus plus I or I plus plus. Now what you need to do? Sum is equal to sum plus kids of I. Now that's it. Now what you are going to do? Simply return sum. That's it guys. Now come on, let's run this particular thing to test our public test cases. Great. So you got accepted public test cases. Now if you consider here, let us check this same thing with our this test case which we have already written, which is our 1000. Let me write it here, 1000. So what is this? 1000, and I request everyone to please keep your pen and paper ready. 1000 533 5, sorry, 5, my bad, 533, I guess it's 4, comma 1 1 200 1200 20,000 is given in constant. If I am running it, I should get 19 as the candies count. Let's see it. So it's running. Great. So it's the first test case, is the second test case. Now this is our third test case. It's great. So we got 19 as the output expected. Fine. Now let's submit this. Okay. Now let me submit this. I just ran it. Now let me submit this. Okay. And now let us see whether our hidden test cases, all the hidden test cases are getting satisfied or not. Yes. So here all our hidden test cases are getting satisfied. You can just observe here. And let me paste it here. So here we got our all hidden test cases satisfied. And let me inform you about the time complexity. Okay, what is our time complexity? Big of n. Why? Because we have used big of n, because we have used our loops. And what about our space complexity? Our space complexity is also big of how much? Excellent, big of n. Why? Because you have used one kids array. You have used one new array, which is kids. That's why. Is this clear to everyone? I hope. Fine. So stay tuned for upcoming lectures, and before winding up this session, let me provide you with another hidden test case. I request you people to solve this. Okay. So let me write here ratings is equal to, now let me provide you a very big number of test case, something like 1 2 5 1 1 20,000 0 0 1 triple nine comma 1 1 triple nine comma 1 double nine. I request you people to please let us know the output. Okay. Namaste and thank you for your valuable time.